Alright, hello math fans. We already learned how to graph a system of equations and find the intersection of the two lines. Now what we're going to do is we're going to use something called substitution. Okay, this is just another method. This is the best method if something is already solved. One of the variables is already solved. So let's start with in the first example here. If I have y equals 2x plus 3 and 3x minus y equals -1. You need to remember that the x and the y are actually the same for both equations. So kind of like when I did graphing, real quickly, little example over here. If I had a graph and let's say the two lines went like this and like this, okay? The solution to this problem was 1, 2. So the x's and the y's are the same for this line and for this line. So if they're the same, I can actually do a substitution. So literally I'm taking this y and I am substituting it into the other equation for this y. Alright, so what I get is when I substitute this in, I'm actually rewriting this equation right here. So I'm saying 3x minus, and I'm going to put a parenthesis in here. The parentheses are actually really, really important. Okay, so whenever you substitute something in, put it in parentheses because this negative needs to be distributed by both of the terms. Okay, so I have 3x minus y. Well, what is y? Well, y, it's right here. I already solved for it. So y is 2x plus 3. So 3x minus 2x plus 3. Okay, that's a substitution. So now I've finished that, and then I say equals -1. So if you notice, this equation is really this equation right here. Okay, so it's 3x minus y. Well, again, the y is 2x plus 3 equals -1. So that's why they call it substitution, because I'm substituting the variable I already solved for into the second equation. Alright, now once you're at this point here, I need to solve for x. You notice I only have one variable. That's the whole point. I'm trying to get it to be just one variable, and then I can solve for it and I can get a value. So, and be careful, make sure you distribute that negative. So I get 3x minus 2x minus 3 equals -1. Combine like terms, so make sure you follow all your steps. So you, just like we learned back in the day, you distribute, then you combine like terms, then you add and subtract, and then your last step is either multiply or divide. You've got to follow those 4 steps. So in this case here I combine like terms, so I get x minus 3 equals -1. I'm going to add 3 to both sides, and I get x equals 2. Okay, that's half my answer. In fact, I'm going to write this as an answer all the way on the right here, 2 comma something. So I need to find out my y value. Well, that's really easy. Notice this one equation up here on top. It's already solved for y. I'm going to take that x and I'm going to plug it back into where I see x over here, and I'm going to find out the value of y now. So y equals 2x plus 3, so y equals 2 times x, which is, that's our x right here, plus 3. So y is equal to 4 plus 3, so y equals 7. So that's my answer. It's 2 comma 7. Now some of you might say, well, can't I plug it into either equation? You're right, you can plug it. I could have plugged it back into the second equation too. So I could have plugged it back into 3x minus y equals -1 and found the value of y. Let's just do that. 3 times 2 minus y equals -1. So again, here's your x's 2. I plugged it back in. If I solve for y, first of all I get 6 minus y equals -1. Subtract 6 from both sides. So -y equals -7. Divide by -1. Y equals 7. So I really got the same answer, But the whole point is why I did so much more work here. I had to solve for y in all these steps when I can just plug it back into the equation that's already solved. Okay, so I want to plug it back into this one right here. Again, that one that's solved, which is this guy right here. Okay, and then once, and that was just a couple of steps here. It's like 3 lines here, as opposed to here, 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 dividing. I mean, all these steps here just to get my answer. Okay, so let's start out with another example. But again, that's the solution to that. That's where, basically, that's where these two, this equation right here, this line and this line, this is where, if I would graph those, that's where those would intersect. Okay, so let's try a new problem. X equals negative 2y minus 1 and 2x plus 3y equals negative 5. Alright, well, notice this first equation, x is already solved. So I don't really have to do a lot of work to solve one equation. Sometimes an equation is not solved and you actually have to solve it and then plug it in. So I am literally going to plug in into there. That's going to be where that x is negative 2y minus 1. I'm going to plug that into that x. So I'm going to rewrite this equation as 2. I'm substituting x into that, so x is negative 2y minus 1. Okay, I literally substituted this x into this x right here. So now, again, I'm rewriting this equation. Okay, I'm rewriting this equation. So it's 2 times x, which is negative 2y minus 1. And I got to continue on. Plus 3y equals negative 5. Alright. Once I have that, I'm basically solving for y. Okay? So I just need to distribute. So remember, I'll follow all the rules. So distribute the 2. So negative 4y minus 2 plus 3y equals negative 5. Okay, combine like terms. So I get negative y minus 2 equals negative 5. I'm going to add 2 to both sides. I get negative y is equal to negative 3. Divide both sides by negative 1. I get y is equal to 3. So there's the first part of my equation. So it's something which is x, which I need to figure out yet, comma 3. Now remember, this equation right here, this first one, it's already solved for x. I don't want to plug it into this one. I don't want to plug it into the second one. I get the same answer, but why do more work? Remember all the steps from the last problem. If you plug it into the second equation, you want to plug it into the one that's already solved. So I have now x equals negative 2y. So negative 2, I'm going to put a parenthesis here where I see the y, and then I'm going to substitute that 3 in there. So negative 2 times 3 minus 1. So x equals negative 6 minus 1, or x equals negative 7. So there we go, negative 7. So that is my answer. That's my solution. All right. So let's say it's not solved for you. Let's say it's a little trickier, and I get negative 2x plus 2y equals negative 6, and 8x minus 5y equals 9. I have to solve for one variable in one of the equations. So I can choose the x or y for the first equation or the x or y for the second equation. Now our goal is when you solve one of the variables, you want to make sure all your terms are whole numbers. If they are not whole numbers, if you, for example, let's just say for example, we solve for, and this is a bad thing to do, but you solve for the second equation. I solve for x. If you notice, I'm going to be dividing everything by, here, let me just write this out. If I would solve this one, and I'd solve for x, I'd have to, I have to add 5 first to both sides, but after that I would be dividing everything by 8 to solve for x. I would get negative 5, I would get 5/8 here, and I get 9/8. That is brutal. You do not, in substitution, you don't want fractions. Okay? Your final answer might come out to be a fraction, but you do not want to solve and have to substitute fractions in. It just makes things so messy. So if you notice, our first equation has negative 2x plus 2y equals negative 6. Okay? So what you want to do is either solve for, in this case here, I can solve for x or I can solve for y. And if you notice, again, I need to subtract or add to move it over. But no matter what, if I divide by 2, I get a whole number, right? This is just a y here. This is a negative 3. So that's what I want to do. I want to solve that first equation for either x or y. And in this case, it doesn't matter. I can do either one. Well, what I'm going to do is I'm actually going to solve for y. All right, so let me rewrite it here. Negative 2x plus 2y equals negative 6. It's my choice. Part of the reason I choose it is because when I add x to both sides, or add 2x to both sides, there's going to be positive values. Okay, I don't have to divide by a negative. Not a big deal, but I'm just trying to make it as easy as I can. So I'm going to add 2x to both sides. So I get 2y is equal to 2x minus 6, and then divide everything by 2. So y is equal to x minus 3. Okay, so now just like the first two problems I did, I have one equation that's solved, and here's my other equation, 8x minus 5y equals 9. And then I am going to substitute that y for that y. So if I write that out, I'm going to get 8x minus 5 times y. Well, again, y is x minus 3. So there it is, x minus 3. And then I'm going to continue the rest of the equation, equals 9. So that's 8x minus 5y, or 5 parentheses x minus 3, equals 9. And then, again, it's solving like normal. So I distribute. Make sure you distribute the negative 5. So you get 8x minus 5x plus 15 equals 9. And then I just solve here. I just combine like terms. So 3x plus 15 equals 9. Subtract 15 from both sides. So 3x is equal to negative 6. And be careful of your signs, guys. Don't make a mistake. Because if you make one mistake solving this first equation for the first variable, your second equation won't be, or your second variable won't be correct because you'll be plugging in the wrong number. So you have to be really careful. So divided by 3, x equals negative 2. Okay, so that's the first part of the solution. So I'm going to write here negative 2 comma something. And then once again, plug it into this equation right here. It's already solved for y. Y equals, well, x, which is negative 2 minus 3. So y equals negative 5. So there we go, negative 5. That is my answer. Now I want to mention one thing. You will have time at the end of a quiz, end of a test, to check your work. It's so easy to check your work. There's no reason to get a wrong answer. You literally take that negative 2, negative 5, and you plug it into both equations. So if I go back, and I'll kind of try and squeeze this in here, but if I go back to these original equations, I want to take the negative 2, negative 5, and I want to plug it in. So if I plug in negative 2, here, this is just, we'll squeeze it in here, negative 2 times negative 2 plus 2 times negative 5. I want to see if that equals negative 6. It better, if it doesn't equal negative 6, then I made a mistake. So I get 4 minus 10, which is negative 6. So that is true. So that's good. And let's plug it into the second equation because it has to work for both. So 8 times negative 2 minus 5 times negative 5 equals 9. So I get negative 16 plus 25, and that does equal 9. That's true also. Okay, so both those are true. That just checks your work. So you have to make sure it works out for you, and it's a great way to check it if you have a little extra time. All right, let's do one more example here of substitution. So I have y plus x is equal to negative 3, and 3x minus 7y equals 1. Well, really the obvious equation that we're going to work with is the top one, because if I divide the second one by 3 or 7, it's nasty. It gives nasty fractions. So just for the heck of it, I'm going to solve for x. In this case, it doesn't matter because y and x are pretty equal here. So I'm going to rewrite this. Y plus x equals negative 3. I'm going to subtract y from both sides. And I'm going to get x equals negative y minus 3. And again, I know most of you are used to solving for y first. Sometimes you'll have to solve for x. And it could be, the equation could be a and b. It might not be x and y. So you don't even know what letters to use, or what letters you're going to be using. So you basically, when you are solving this, by the way, if it is a and b, it's always a comma b. Just like it's x comma y, you put it in alphabetical order. Okay, so it could be I comma j, oops, I comma j. Okay, so always alphabetical order. Okay, so we solve the first one, and then I'm literally going to substitute that into this x right there in the second equation. And please do not substitute it back into the original problem. So I've had it in the case where people say, oh, it's y plus, and they substitute that negative y minus 3 into the original equation. Everything would cancel out, and you wouldn't get an answer. Okay, so we have 3 times x, which is negative y, minus 3. Then I continue the equation, minus 7y equals 1. Distribute, so I get negative 3y minus 9 minus 7y equals 1. So I get negative 10y minus 9 equals 1. Just going to finish it over here. Let me just rewrite this. Negative 10y minus 9 equals negative 1, or equals 1. So I'm going to add 9 to both sides. So I get negative 10y equals 10. Divide both sides by negative 10. So y equals negative 1. Okay, that's the first part. And once again, this is solved right here. So I plug in negative 1 for y. So I've told you to use parentheses. So basically, it's negative of parentheses minus 3. Well, we're going to plug that negative 1 in there. Okay, so two negatives give you a positive, so x equals 1 minus 3. So x equals negative 2. So your solution to this problem is negative 2 comma negative 1. Once again, I can plug this back in to both equations. If I do that, you'd see that the point actually worked. Okay, so that's it. That's substitution. Just one little tip, because we're going to be learning one more method too, is here like in this problem, you actually had to solve for y, or you had to solve for x. A lot of times you're going to be using substitution if a variable is already solved for. Okay, so if the problem actually started out like, y equals 5x minus 3 and 2x plus 5y equals 105, something like that. Okay, that's already set up as a substitution problem because it's already solved, and you literally are going to substitute that 5x minus 3 into the y. Okay, so if it's already solved, substitution is the best. All right, math fans, that's all I have to say. Have a nice day. Goodbye.